currently doing a project at National Grid, changing out insulator strings because the insulator strings were made in 1902, and we do it energized because it's a line that can't be taken out of service for various reasons. So we had to develop a method with using Baker boards and various other pieces of equipment that will allow us to do it energized.
Haverfield uses Baker boards as an outward extension of an existing structure. They are very similar to a diving board. They stick out at 90 degrees to one of these structures. Men can work on these things very similar to how somebody would work on a diving board. They can walk back and forth on them.
They call it a Baker board because one of the original ones, evidently the name of the company was Baker, and they were made out of wood, varnished wood years ago, but they've evolved, and the ones we use are ones that we've designed, and they're made out of an extruded fiberglass non-conductive fire retardant material.
Haverfield's synonymous with effecting bare hand repairs on the phase conductors, particularly in areas where ground-based methods cannot reach it with any methodology.
By bringing in Haverfield, they're able to eliminate all of the concerns about bringing trucks onto the right-of-way, bringing reclamation, what they call reclamation and matting, on areas where they may need to leave the right-of-way. You might have wetlands, you might have farmers' fields, there's landowners where these right-of-ways are landlocked, and you've got people that are not willing or wanting the utilities to trespass basically on their property. So when you bring Haverfield in, we bypass all of those issues and we're able to access the lines without having to put a footprint either in the right-of-way or the connecting landowners.
Remember, this is energized work. We've got to make sure we keep our minimum approach distance. Our phase to phase is 4.5. Phase to ground is 3.5. So keep that in your mind. Don't get too comfortable. Everything's tight up there.
Normally, we would arrive on site in the morning and have a tailboard discussion about the work that's going to be done that day. We would get all the equipment out. The equipment has to be tested, and every day the helicopter will fly us to the structure. Depending on the type structure, sometimes we do a skid transfer from the aircraft to the structure, or if the top of the structure is congested or there aren't a lot of handholds or footsteps on the structure, we'll do a long line transfer, fly people out suspended from a long line beneath the helicopter, get them on the structure. Once the crew's on the structure, the helicopter will begin the process of moving all the required equipment to the structure, and it'll take numerous trips to achieve that. We have to fly ladders out, hang ladders on the structure on both sides, and we have plates that have to be hung from the structure, hot sticks. There's quite a bit of gear that has to be installed on the structure. We have a fiberglass Baker board that we use, and that has to be flown out. We have a design that we've come up with that works very well on these structures that allows us to land that Baker board on brackets that we've fabricated for the different type structures that are out here, and we attach that board to the brackets and position it under the conductor, and we have a means on there to raise the conductor and disconnect it from the insulators and then slide the conductor out of the way. That allows us to change the insulators and also change the attachment hardware on the structure that holds the insulators. It's worn also. And while that's being done, the helicopter returns with a long line. We lift one of the linemen out, position him on the Baker board, and he energizes himself and then changes the conductor's shoe that is on the wire and performs any necessary repairs if there's any worn or damaged areas on the conductor. This particular line is a double circuit line. We have 6 locations that we will do with the board on a tangent structure, an inline structure. And Some of the structures are double dead-end structures. When we do those, we actually do 2 baker boards at the same time because the glass, instead of hanging vertical, it's horizontal. 2 strings of insulators per phase, and the wires double dead-ended.
Haverfield brings speed, Haverfield brings efficiency, Haverfield brings cost savings. Haverfield has defined specific applications that support the utility market in a way that benefits not only them but their customer. Haverfield brings an evolution that hasn't been seen in normal business circles. And that's important because that's a team concept that Haverfield has defined and grown with. When the utility comes to Haverfield, they're going to get their nickel's worth.